New technologies of the future that are already with us in 2022. It's a magnificent era we are living in. AI and robotics are coming with weekly breakthroughs, with amazing discoveries and inventions. Very soon, we'd leave all the struggling and troublesome jobs to them, and we'd just relax. So let's see, what new technologies of the future are already with us in 2022? Hello everyone! Welcome to my channel. Don't forget to subscribe and like, and also press the bell icon to never miss an update about artificial intelligence, robotics, and future technology. That being said, let's begin. Quadruped robots inspired by ants work cooperatively to conquer difficulties. When a foraging ant comes across a gap that is too large for it to cross on its own, it will occasionally signal other ants to create a bridge out of their connected bodies. Such behavior has now been replicated in a tiny four-legged robot, which might lead to the development of better search and rescue robots in the future. Quadruped robots have several benefits over wheeled robots, including the ability to walk over and around obstacles when navigating tough terrain. As a result, collaborative swarms of such robots are expected to be used in applications like hunting for survivors at disaster sites. Deep chasms or impediments that are too steep to climb can, however, stop even-legged robots. With these restrictions in mind, Assistant Professor Yasemin Özkan-Aydın of the University of Notre Dame created a batch of 3D printed four-legged robots that can work together to overcome them. Each one is 15 to 20 centimeters, 6 to 8 inches long, and has a lithium polymer battery, a microprocessor, a front-mounted light sensor, and one front-mounted and one rear-mounted magnetic touch sensor. When the bot becomes trapped by test objects like wooden blocks affixed to particle board, it transmits a wireless signal to other robots nearby. Özkan-Aydın is focused on enhancing the swarm robot system's sensitivity, collaboration capabilities, and battery capacity. It might eventually be used in applications like space exploration, environmental monitoring, or researching the collective dynamics of insects like ants and termites, in addition to search and rescue operations. Next, scientists transformed a genetically engineered dragonfly into a drone by attaching an electrical backpack to it. Scaling down machines gets quite tough at a certain point. There's just so little a drone can be. Draper scientists have devised a solution: create a drone out of a dragonfly. The nerve terminals of a dragonfly's spinal cord were genetically changed by researchers at the Howard Hughes Medical Institute, HHMI. Draper's team then connected a backpack that is powered by a small solar panel and can control the dragonfly remotely using light flashes. It enables them to direct the insect where they want it to go. Is the experiment in any way harmful to dragonflies? Entomologists think that insects do not experience pain in the same way that humans do. Furthermore, the technique has certain significant uses. It may, for example, be used to replace bees utilized by farmers or to monitor the health of beehives uniquely. Cyborg insects might be utilized as surveillance equipment in the future. Next, a small cockroach robot might be the future of catastrophe search and rescue. Nature has inspired some of the finest robots. Engineers have now created a little, scurrying bot modeled on the common cockroach that has nearly the same speed and squashability as its biological counterpart. The as-yet unnamed soft robot, which is about the size of a postage stamp, can move at a pace of 20 body lengths per second and withstand 1,000,000 times its weight in tension. The bot, which weighs less than 1/10 of a gram, can endure being stepped on by a human foot, weighing around 60 kilograms. It simply gets up and goes about its business. Most of the robots at this scale are fragile, says Li Wei Lin, a mechanical engineer at the University of California, Berkeley. Stepping on them will effectively destroy the robot. The robot's resilience is due in part to its straightforward design. It's made of a thin sheet of PVDF, or polyvinylidene difluoride, a piezoelectric material that expands and contracts with the application of a small AC current. The Roach ability bots to move is due to this expansion and contraction by adding a front leg and an elastic polymer layer. The scientists were able to bend the sheet in a way that pushes it forward. To change the running speed of their ideas, the team experimented with different lengths of the robot, from 10 to 30 mm, and different frequencies and voltages to electric current. When 200 volts was delivered at 850 Hz, a 10 mm robot could skitter along at a blistering 20 cm per second. A small robot designed by Chinese engineers can climb, move through tunnels, and carry things up to 6 times its weight. Currently, the bot must be connected to a power source, but a future iteration might be powered by a small battery. Investigating catastrophe locations that may be risky and unstable is one way small bots might aid. The team is investigating how to include a gas sensor into the original design, which would allow the robot to enter very small locations and detect any gas leaks that may pose a life-threatening hazard. One of the enhancements the engineers want to make to their soft robot is this. They also want to figure out how to have it automatically avoid impediments as it explores the world. Next, there are cyborg beetles, which are real insects that are controlled by robots. On 6 legs, the future is creeping towards us. Dr. Sato, an aeronautical engineer from Nanyang Technological University, met with Motherboard in Singapore. By electronically regulating the motor activities of live beetles, Sato and his colleagues can convert them into cyborgs. The researchers connected the beetles such that they could be controlled by a switchboard. After studying their muscle architecture, neurological networks, and leg control, the researchers were able to modify different walking gaits, speeds, flying directions, and other sorts of motion in this way. Furthermore, transforming beetles into cyborgs does not appear to be damaging to them. Their normal lifespan is 3 to 6 months, and they can live for several months even with the researchers meddling. A beetle has never perished after being stimulated, according to the experts. While this technology may appear to be insane, the consequences are quite practical. Sensors that sense heat and hence people may be implanted in the beetles, causing them to crawl toward a person. When looking for someone, such as in a criminal investigation or tracking down a terrorist, this can be useful. The researchers are committed to ensuring that whatever uses this technology may have, they are used for peaceful reasons. And who knows how far it will spread. With so much success in influencing the motor processes of organisms as little as beetles, it may be applied to larger animals. Next, there's the robo-replica dragonfly. The dragonfly flaps its wings faster than insects. No matter how amazing our human designs are, evolution has a 4 billion year head start. So plagiarizing Mother Nature's homework isn't a bad idea. Engineers at the University of Bristol have done exactly that, and even better, by creating a small flying robot with a unique electrostatic zipping mechanism that flaps its wings more effectively than an insect. Drones inspired by birds and insects, such as Harvard's Robo-Bee and the Delphi Nimble, have been flying around for years. While they may do some impressive aerial movements, they normally rely on complicated transmission systems, such as gears and motors to fly. The new drone from the Bristol team employs a liquefied amplified zipping actuator, LAZA, an artificial muscle technology that requires no transmission. Each of the dragonfly-sized drone's wings consists of an electrode protruding from the base between 2 smaller electrodes. A strong voltage is provided in an alternating sequence across each of the base electrodes, attracting the wing electrode to each one in turn. If you do it quickly enough, a flapping motion is created, which is magnified by a liquid dielectric between the electrodes. We put electrostatic forces directly to the wing with the LAZA, rather than through a sophisticated, inefficient transmission system, said Tim Helps, the study's principal author. This improves performance and simplifies design, allowing for the development of a new class of low-cost, lightweight flapping micro-air vehicles for future applications such as autonomous inspection of offshore wind farms. It was capable of flying across a room at a speed of 2.5 km per hour or 18 body lengths per second in testing. According to the researchers, the LAZA technology might eventually lead to smaller, more maneuverable drones that could be used for environmental monitoring, exploration, search and rescue, or even plant pollination. The Arduino Spider Robot Quadruped is the next project. Arduino completed this project in just 7 days, taking 2 days to complete the hardware and assembly, followed by 5 days to write the code and Android app. This guide contains enough papers and code to allow you to quickly develop your crawler. Because these devices are so pricey on the website, we've put this step-by-step guide to help you make your spider-bot. The robot, as its name implies, is a rudimentary approximation of the spider motions. However, it will not do the same body movements because we are only utilizing 4 legs instead of 8. The robot is also known as a quadruped robot because it has 4 legs and moves with them. Each leg's movement is linked to the movement of the other legs to determine the robot's body position and to manage the robot's body balance. Legged robots are better at handling terrain than wheeled robots, and they move in a more diverse and animalistic manner. However, this complicates legged robots and makes them less accessible to many creators. Also, because it is reliant on servo motors or stepper motors, both of which are more expensive than DC motors, that might be used in wheeled robots. The manufacturing cost and high defenses that a manufacturer should invest to produce a full-body quadruped. Because 4 legs allow for passive stability, or the capacity to stay upright without actively shifting posture, quadrupeds are abundant in nature. Robots are no exception. A 4-legged robot is less expensive and easier to build than one with more legs. Yet, it can still maintain stability. A servo motor is used here. Although the word servo motor is typically used to refer to a motor appropriate for use in a closed-loop control system. It is not a specific type of motor. In most cases, the output high voltage is between 2.5 and 10 volts, with 3 volts typical. Low voltage output spans from -40 millivolts to 0 volts. You can control the entire system using an Arduino Nano, and I've built a robot Spiderform to make this project even better. The Android app allows you to connect to your robot through Bluetooth and make forward and backward movements, as well as left and right turns. It also allows you to change the color of your robot in real time by selecting the desired color from a color wheel. You need to connect the OLED display after uploading the code to display the Cosmo Robot grins that I created in the main code. The next robot is Scorpion, a biomimetic walking robot. The Scorpion is an 8-legged walking robot designed for use in dangerous outdoor environments. It can travel to places where other robots are causing problems. It employs a biomimetic control mechanism that enables extremely flexible and stable walking. The Scorpion robot's walking gaits are based on studies into the movement patterns of genuine scorpions. With a GUI and optional voice control, the Scorpion may be controlled straightforwardly. The established models of biological motor systems allows the robot to adapt to a variety of terrains and obstacles on its own. Exploration of hazardous areas, such as in SAR missions, might be a future field of use. The Scorpion is now being developed as an amphibious variant. At NASA's Ames Research Center, a duplicate of the Scorpion is being used to assess the benefits of legged systems for interplanetary missions. Finally, there's the robotic butterfly, Festo. A German business invented e-motion butterflies, a robotic butterfly. The drone is the term for such a robot, and this butterfly is essentially a drone. E-motion butterflies, on the other hand, is inspired by nature. Unlike the gadget with 4 propellers, the ability to fly is achieved by moving the wings like that of a real insect. That is very unique. Festo uses such capabilities to illustrate not only the potential of a coordinated robot to multi-fly, but also the capability of downsizing and lightweight construction. Infrared cameras detect their location, and each butterfly's movement is regulated based on the information. These are extraordinarily light for flying vehicles, weighing only 32 grams. The bodies are laser sintered once more, and the wings are made of carbon fiber rods. The body and each wing are equipped with 2 small servo motors. A microprocessor, an inertial sensor like a gyro, accelerometer and compass, and 2 radio modules make up the electronics. The flight time is around 3 to 4 minutes. With this being said, today's episode of our weekly updates on the newest futuristic technologies and robots comes to an end. Next time, we'll bring you even more exciting robot news. Subscribe to the channel to stay up to date with us. We'll see you at the next one. Until then, peace.